The test of a first-rate intelligence is the ability to hold two opposed ideas in the mind at the same time and still retain the ability to function. Francis Scott Fitzgerald.
Appendix 4, on physical fields.
In this chapter, yet another possible interpretation within the paradigm of the great life will be presented, a new understanding of the nature of physical fields. Let us rewind history by a few hundred years, back to pre-Newtonian times. Back then, everything was simple. Physics was reduced solely to mechanics, and physical bodies were supposed to act directly upon one another with a certain force, producing a corresponding acceleration. Later, physicists discovered with surprise that some objects act upon one another at a distance. These investigations forced scientists to introduce into usage the concept of a field as a special form of matter, a kind of mediator of interactions between particles, elements of matter. Within the paradigm of the Great Graveyard, modern physics operates with the following physical fields.
The nuclear force field.
This field describes the so-called strong nuclear interaction. It acts over very short distances and allows neutrons and protons to combine into atomic nuclei and to keep those nuclei in a stable state.
The electromagnetic, electric and magnetic field.
These fields act on electrically charged particles and on bodies possessing a magnetic moment. Owing to this field, atoms of different kinds are able to bind into molecules, while atoms of the same kind are able to assemble into crystalline structures.
The gravitational field.
Through this field, interaction is carried out between all objects that possess mass. Physicists believe that it is precisely the gravitational field that shapes the structure of the universe, creating stars, planets, galaxies, and the like. As you understand, all of this consists of formulations of the paradigm of the Great Graveyard. But what is a physical field in our paradigm? Here we have one object. Here we bring another one close to it, and for some reason, these objects begin to interact at a distance, for example, to attract one another. Can we describe this interaction without resorting to the concept of a field? Of course we can. Here you go.
Certain objects, when near one another, change their normal behavior.
And if we additionally imagine that we are not talking about some inanimate objects, but about subjective entities, and we have already arrived at the understanding that the entire universe consists solely of subjective entities, then, without invoking the concept of a physical field, their interaction at a distance can be described as
certain subjective entities are capable of changing one another's behavior.
Let us think about whether there exists in our warm and cozy world of cells, organisms, and mind some analogue of electric charge. In the micro-world, certain subjective entities are binary, divided into two camps, between whose representatives something inexplicably miraculous occurs. They either gravitate toward one another or, on the contrary, cannot tolerate one another depending on which camp they belong to. What could that possibly resemble? Well, of course, it resembles the division of representatives of our world into two opposite sexes and their mutual attraction and repulsion. Only the representatives of our world are far more complex than those of the micro-world, and therefore the forms of attraction-repulsion in our case are incomparably more complex. In other words,
when it comes to describing interactions of complex, living, intelligent and superintelligent beings, the concept of interacting fields ceases to work. Instead, we are forced to use the terms of psychology, attraction, sympathies, antipathies, sociology, competition and cooperation, free will, and the like. Field theory works only when we are modeling interactions of very simple proto-living entities, elementary particles.
In the modern physical theory of the quantum field, all subatomic particles are considered as being generated by a field. That is, each such particle represents merely a local oscillation of a field of a certain type. Let us examine one of the central theses of this theory, which sounds as follows.
Everywhere in the world around us, myriads of fields simultaneously exist. Quark fields, electron fields, proton fields. These fields can interact with one another. Energy from oscillations of one field is captured by fields of a similar type.
Let us once again try to rephrase this in such a way as not to mention the word field at all. So,
everywhere in the world around us, myriads of models of the universe simultaneously exist. Models of the universe of animals, models of the universe of plants, bacteria, and proto-living entities. If the model of the universe of certain subjective entities contains concepts of other entities, then upon encountering them, the behavior of those subjective entities is modified.
at this point, it is high time for the reader to protest.
How can the author compare the micro world of atoms and organic chemistry with our macro world? In the physics of the micro world, interactions of particles and fields are predetermined. We can predict with known precision the behavior of, say, an electron in an electric field. But in our macro world, we cannot predict even the behavior of, say, two insects, let alone two teenagers of opposite sex. Your generalization of the micro and macro worlds simply does not work.
To this I would reply, yes, the macro world is very poorly predictable, but for some reason we constantly forget that the micro world is far from being predetermined 100% as well. For example, when speaking of the nuclear force field, are atomic nuclei really so stably predictable? From time to time, they act willfully, spontaneously, without any visible external influence. They decay into corresponding fission fragments. Why should that be? And is the behavior of those same electrons in electromagnetic fields really so rigidly determined? For instance, among millions of electrons, there are always, for some reason, stubborn individuals that somehow inexplicably overcome a completely insurmountable potential barrier. To clarify, this refers to the so-called tunneling effect when a certain potential barrier is overcome by a microparticle whose total energy is significantly lower than that barrier. The tunneling effect is observed for all elementary particles in a wide variety of physical systems. So then, is the tunneling effect not an example of willfulness on the part of charged particles? And as for the gravitational field, something entirely inexplicable is happening there at all. It would seem that nothing could possibly shake Newton's law of universal gravitation. Two bodies possessing mass should always attract one another with a strictly defined force, right?
Well, right, except that this is far from always the case.
First, the mass of bodies themselves for some reason changes over time. In 1875, after the signing of the metric convention, about 40 platinum-iridium reference cylinders with a mass of exactly 1 kilogram were manufactured. These standards were distributed to various countries to ensure uniformity of the system of measures. Periodically, all these copies were compared with the original kept in the suburbs of Paris, and measurements showed that under strictly documented identical storage conditions, their masses for some reason gradually began to diverge. In some countries, the standards were losing weight, while in others, on the contrary, they were increasing their mass, And at different times in different countries, these processes proceeded at different rates. Now, after 150 years, it is already completely impossible to determine which of these 40 standards represents the true kilogram. The mass values of all the standards have diverged so greatly. I mention this because if mass changes over time, then the gravity induced by that mass must also change accordingly. How, then, can gravity be considered unchanging? But that was only first. And second, we observe entirely strange miracles of gravitation in outer space. According to Kepler's famous law, as the distance from the center of rotation increases, the angular velocities of celestial bodies should decrease. And this is exactly how all the planets of our solar system behave. But stars, galaxies, and clusters of galaxies behave in a completely different way. They move as if they were fixed to rigid disks, the subjects of the cosmic superintelligence, both near to and far from the center of rotation, rotate with the same angular velocity. This means that as a star moves farther away from the center of rotation of its galaxy, gravity does not decrease, but on the contrary, increases. Within the paradigm of the Great Graveyard, this increase is explained by the presence of that very dark matter we discussed in the chapter, The Hierarchical Nature of Life. However, there is no understanding whatsoever of how the substance of this dark matter manages to accumulate in the disks of galaxies, and not uniformly, but ever more densely as one moves away from the center of rotation. Within our paradigm of the great life, however, such behavior appears to be explainable. In that same chapter, The Hierarchical Nature of Life, we established that one of the basic skills of all subjective entities is the striving to unite with friends, that is, cooperation. It seems to me that the tendency of all bodies possessing mass to attract one another is precisely a manifestation of that very cooperation. In outer space, this cooperation manifests itself differently for planets and for stars. It appears that superintelligent subjective entities, stars, cooperate more tightly, for to them a galaxy is something like an ant-hill for ants. There is nothing surprising in this. After all, it does not surprise us that, for example, at our level of the hierarchy of life, the degree of cooperation among members of one family may be many times higher than the degree of cooperation among, say, barely acquainted residents of an apartment building, right? I am convinced that there must be far more unexplainable oddities of the gravitational field. We are simply incapable of detecting them, let alone explaining them. Cells are likewise incapable of detecting, let alone explaining, all the movements of Missy across the lawn solely by the jolts and accelerations they observe. Well then, I hope that by now the reader has acquired, at least at a qualitative level, an understanding of the following.
A field is merely a convenient mathematical model, naturally introduced within the paradigm of the Great Graveyard, to describe the behavior of lower forms of life.
Before closing this chapter, I want to make one more reservation. We are not challenging field theory here, at least with respect to electric and magnetic fields, where this theory deals with very primitive proto-living entities. It demonstrates excellent predictive power.
Summary.
When it comes to describing the interactions of complex, living, intelligent and superintelligent beings, the concepts of interacting fields cease to work. Instead, we are forced to use the language of psychology, attraction, sympathies, antipathies, sociology, competition and cooperation, free will, and the like. Field theory works only when we are modeling the interactions of very simple proto-living entities, elementary particles. The gravitational field is the striving toward cooperation of all subjective entities of the universe without exception. A field is merely a convenient mathematical model, naturally introduced within the paradigm of the Great Graveyard to describe the behavior of lower forms of life.